Hello and good afternoon, everyone. Thank you for joining us this afternoon. My name is Jason Dadakis, and I serve as the Executive Director of Water Quality and Technical Resources here at the Orange County Water District. And I'm excited to welcome you and host today's webinar. We have a great presentation ahead of us this afternoon, highlighting the impact that per and polyfluoroalkyl substances, or PFAS, have had on our analytical laboratory here, and also in the lab of our next door neighbors, the Orange County Sanitation District, with whom we have a long-standing partnership for water recycling. I'm personally very excited to hear how our lab professionals have been dealing with increased demands for PFAS analysis, while also coping with new and evolving regulatory requirements. Before we begin, I just want to mention that we are in webinar mode through Zoom, so attendees are automatically muted to reduce background noise. The webinar is being recorded and will be available on the Orange County Water District website, as well as on our YouTube channel. Lastly, we'll be taking questions at the end of the presentations. So we encourage you to submit your questions in the Q&A box located at the bottom of your screen. We recognize that PFAS is a broad topic, and there's lots of public interest in many facets of PFAS. But today we're going to focus on addressing questions that are most relevant to our speakers and the information they're presenting today about the analytical laboratory environment. In the event we're not able to get your question during the time frame allotted, we're happy to follow up with you after the webinar and provide you with a response. So please include your email address with your question if possible. So undoubtedly, PFAS has become a central issue to many utilities and communities, affecting many aspects of the water and wastewater sectors. Here in Orange County, our district has swiftly and proactively addressed PFAS occurrence in our groundwater basin by shutting down impacted wells, implementing a comprehensive well treatment program, engaging applied research, and prioritizing stakeholder outreach. The PFAS situation for utilities is changing rapidly, particularly on the regulatory side. I'm sure most of today's attendees are aware of US EPA's recent formal proposal to regulate 6 PFAS chemicals in drinking water nationally, as well as similar efforts by individual states. But today we really want to give our speakers the opportunity to highlight the impacts they've seen in their analytical laboratories. So I'll close with this. OCWD has a dedicated PFAS education center on its website. It contains lots of great resources and information on PFAS and our related programs, as well as the latest regulations, and also how you can get involved to help hold polluters accountable. So without further ado, I would like to introduce our first speaker for today, Prem Parmar. Prem is the laboratory director for Orange County Water District's Philip L. Anthony Water Quality Laboratory. He's responsible for the direction, management, and supervision and coordination of operations within the lab, overseeing a group of more than 30 highly trained professionals. Prem manages the lab's strategic and advanced planning activities, compliance with state and federal laboratory regulations, and ensures the lab meets both its quality requirements as well as its turnaround reporting times. The lab is responsible for a wide range of testing, including compliance monitoring for local groundwater users, as well as the district's groundwater replenishment system, recycle water project, in addition to general support of the district's groundwater management activities. Prem has more than 14 years experience in the environmental and analytical chemistry field and has worked for the district since 2006, when he began as a laboratory intern while completing his degree in chemistry at UC Irvine. Prem, I'll turn it over to you now. And really thank you for being with us today. As we all know, you're still recovering from the Lakers' recent NBA playoff sweep defeat. So welcome, Prem.
Thanks, Jason, for that. I think what Jason neglects to acknowledge is that I've temporarily retired my Laker fandom during the LeBron era. I'm more of a Kobe fan. What can I say? But thank you, Jason, for the intro. Very excited to have this opportunity to speak to all of you today about our laboratory here at the Orange County Water District, and just describe some of the things that we do to support our community that we live in. So yeah, I'll take you guys into a little bit of the background about our lab. And I know that most people are here to hear about PFAS today, but I did want to highlight some of the other testing that we perform here in our lab. I think it's really important to acknowledge all of the facets that our laboratory works in. And then after that, we'll talk about some of the recent regulatory challenges that we've faced from the California water boards and some of the recent changes that they've made and how that's affected us and our workflows and some of the things we've done to accommodate that. And then after that, I'll talk about our LIMS system, so our Laboratory Information Management System, which is basically our lab database where all of our data is stored. It's also how all of our staff work on a daily basis. So I'll talk about how we've been using an outdated system, and we've recently upgraded to our own in-house system supported by our information services team here at the district. And then the hot topic of the day, PFAS, of course. Everyone wants to know how are we handling an increasing workload. I'll take you through some of the history of our lab's journey with PFAS, dating back a little bit over a decade now. And yeah, so with that, who are we? As Jason mentioned, we're the Philip L. Anthony Advanced Water Quality Laboratory, named after former board director Phil Anthony, who served on our board for 37 years. He was a huge supporter of our lab and understanding that the need for high quality data to make decisions throughout the district. So he's always been a huge supporter of us. The new building, well, new-ish building that we currently reside in, opened in 2009. And he was one of the main reasons that we have this state-of-the-art building that we work in today. And we very much appreciate it. We are very lucky to be able to work in this type of a facility. So we're broken down into 3 separate subsections. So we have our inorganic section, who resides on the first floor. We have our organic section, who's on our second floor, and then a relatively new QA/QC section of a team of 3 that resides on the first floor as well. I'll talk about them a little bit once we get to the regulatory section of this talk. So in total, we're comprised of 33 full-time staff, as well as 5 student interns who come to us from various local universities like Cal State Fullerton, Cal State Long Beach, and UC Irvine. One thing to note, the picture on the left there is a little bit outdated. That was a pre-COVID photo. We've had a number of retirements since then. We haven't had a chance to take an updated photo since the pandemic, but yeah, just wanted to acknowledge that. And one other fun fact that came across while I was putting together this presentation, the lab operations actually began in 1973, making this year the 50th anniversary of our laboratory's operations. So I think it's a testament to the work that we do here, and very proud to say that we've been in operation for this many years, creating high quality data. Some stats about our lab. So on an annual basis, we perform about 20,000 samples, which equates to about 400,000 separate analyses. We maintain 50 separate unique testing methods. Some of these methods are capable of analyzing up to 90 compounds, like our semi-volatile organic analyses. Some methods can only analyze for 1 compound, like hexavalent chromium or perchlorate. Fields of accreditation, so those are the compounds that our lab is certified for by the State Water Board. So we're able to analyze for 245 separate compounds, but our total number of analyses available is at 486. So basically what that means is we perform 245 separate compounds for compliance, but then we also have another almost 250 compounds that we perform in support of the district and to try and look forward ahead of regulations that may be coming down the line. Things like pharmaceuticals, personal care products, nitrosamines, things that are not regulated yet, but maybe down the line. We have 12 analytical instruments in our inorganic section and 20 separate analytical instruments in our organic section. It's important to note that doesn't include all of the various support equipment that we use, like block digesters, extraction units, concentrator units. So it takes a lot of various equipment to operate in a laboratory of our size. Our normal data turnaround times is roughly 2 to 3 weeks. We try to get our data out as quickly as possible to our end users so that they can make the decisions and do with that information what they need. And this is just a listing of some of the major types of chemicals that we perform in our laboratory. In our inorganic section, we have trace and alkali metals, anions, inorganic disinfection byproducts, hexavalent chromium. Those of you who've seen Aaron Brockovich, you may recall some of the hazards related to that particular compound. Over on the organic section, We have PFAS, of course, volatile and semi-volatile organics. I mentioned nitrosamines and 1,4-dioxane. We actually perform our own in-house developed methods for those two sets of chemicals that were developed almost 2 decades ago by our former laboratory directors, Steve Fitzsimmons and Lee Yu. So as it stands today, there are no certified drinking water methods for nitrosamines analysis. So in the last 20 years, we've been producing data through these in-house developed methods. So that's something we're very proud of. I also mentioned pharmaceuticals and personal care products. We perform those analyses in support of our recycling water plant here on site. And so that's a little bit about us, and then we'll go into the regulatory challenges that we've recently faced. So the California Water Boards operates a program called the Environmental Laboratory Accreditation Program, which is basically to certify all water, food, and hazardous waste laboratories in California. What that basically means is any laboratories that are producing data for compliance purposes in California must be certified by this program. Labs need to recertify every 2 years. Our current accreditation runs until February 28th, 2024. So very soon we'll be applying for recertification. On an annual basis, our lab's required to perform blind sample testing or performance testing. We actually just concluded our annual testing this week. And so what that entails is basically we order sets of samples that have chemicals with concentrations unknown to us. We perform our methods for the 245 compounds that we're certified for, and we report the results back to the vendor. And then we receive a passing or failing grade based on the recovery ranges that are allowed. So yeah, we're required to do this every year. If we fail, we lose our certification. So it's very important testing. And then on a biannual basis, so every 2 years, we're required to perform a third-party assessment or an audit. And how that works is basically we hire somebody from the outside to come and audit our processes. They look through all of our methods and our systems to make sure that we are following the rules that are set forth by the water boards. And so in 2021, ELAP adopted the TNI 2016 standard. Basically what the TNI 2016 standard is a set of rules for laboratories to follow. Prior to the adoption of these rules, it wasn't explicitly clear on some of the things that were required by labs to maintain accreditation with ELAP. What level of training is required, what level of QC is required. And so the TNI standard basically standardizes everything for all labs within California. The concept is good. As I said, it standardizes practices across lab to lab. So promoting consistent data generation, no matter which lab you go to, that's the goal. It does create a significant burden for labs, though, particularly smaller ones that weren't previously required to perform this level of documentation and traceability. It is a lot of extra effort, and it requires additional internal audits of your entire system and methods. So we have to dedicate staff time and resources towards conducting these audits, responding to the findings, documenting all of that. And so in 2018, we added a quality administrator. In 2019, recognizing that wouldn't be enough to handle this workload, we added a QA/QC chemist. And then again in 2022, we've added a third member to that team to support these new requirements. Additionally, we incorporated a software called Qualtrics Compliance Software in 2021 for document management. With the number of documents we maintain, we needed a centralized location where we could store everything. Prior to Qualtrics, we were doing everything through like Windows File Explorer and emails, and it became almost impossible to try and keep track of everything. And so Qualtrics has centralized that all in one location, all of our SOPs, flowcharts, corrective actions, trainings. It's automated the tracking and revision history and the archiving of expired documents, which is one of the real keys in TNI that we have to keep track of. And it's also had these built-in workflows, and we can also build our own workflows that we can share with other users. So this is just the dashboard that every user sees in Qualtrics, and it shows me my list of documents that I need to go in and approve. And this is the centralized location. It does look like a standard Windows file explorer, but it's much more powerful than that because Qualtrics allows us the capability to link these documents to different workflows at different times. So for example, if we were operating at this time under revision 4 of an SOP, and now we've moved to revision 5, it keeps track of those dates so that we know at what point we were doing what. So it's really helped us to remain in compliance. This is one of the examples of the workflows in Qualtrics, a corrective action workflow that we're required to perform for TNI. So basically, it runs through all these steps, and Qualtrics manages the entire process. We're able to go back and forth when there's comments on different points of the process, and it keeps track of the entire thing until the close of that document. So it's a very handy tool that's helped us to maintain all of the regulatory challenges that we face. So now let's go into our LIMS upgrades. So in 2001, we adopted the Aspen LIMS software, and we've been using it ever since. It was built on the Microsoft Access platform, which is a bit dated, by a company called Dadakis Incorporated. They ceased operations somewhere around 2010 to 2012. I couldn't find the exact date, but basically what they told us is that we are no longer supporting Aspen software, and they kind of left it to us to figure it out. And so our information services team, they did a really great job in supporting this software and keeping us afloat up until today. And also in 2014, Microsoft discontinued their support of Access 2000, which this was built on. So we began to have frequent data corruption issues and a lot of instability. And so all of those problems led us to eventually decide to try and build our LIMS in-house. Our IS team decided that they felt they could build that themselves, and they have. And so we began what we call the Citrus LIMS project, Orange County Citrus. So it was built on a SQL Server database system, which is more advanced than the Access platform we used to be on. Developed across 5 separate phases. So we started with sample login because that's the genesis of the work we do. Once the sample is logged in, we can begin work. Out to our RIMS data transfer. So RIMS is our water resources management system. That's the system that our data end users, the other departments of the district, that's where our lab data eventually goes for them to use for their purposes. And then from there, the next 3 phases was just folding in all the different methods and workflows that we perform in LIMS. We started with metals and our organic GCMS methods, moving on to our IC and LCMS methods, and then other manual wet chem methods. One thing to note on step 4, we actually started to incorporate the capability for tablet data entry that our IS team developed a web tool that we're able to sync with our LIMS so that we no longer have to enter data into like a physical notebook and then manually transcribe into our LIMS. Reduces transcription errors, reduces paper use. And then phase 5, other Aspen tools and functionality that we had that we needed to bring over to our in-house LIMS. So that takes us to today, where we've just very recently discontinued our use of Aspen LIMS, and we are fully operating on our Citrus LIMS platform now. We're continuing to update our functionality regularly. We have many more workflows and functions that we want to build in this new LIMS, including things like barcode scanning. Currently, we enter all of our sample information by hand. And I mentioned we have 20,000 samples annually, so that's a lot of manual data entry. And eventually, we want to be able to go completely paperless with our data reporting and reviewing. So that's our LIMS. And so now for the topic of the day, PFAS. So our lab's history with PFAS dates back to UCMR 3. So for those that don't know, UCMR is a federally run program by the EPA. Stands for the Unregulated Contaminant Monitoring Rule. It runs every 5 years. Basically, the purpose of UCMR is to collect data for contaminants that are suspected to be present in drinking water, but do not yet have health-based standards under the Safe Drinking Water Act. So at the time, about a decade ago, PFAS was not yet regulated. And so we participated in the UCMR program. Initially 6 compounds with reporting limits ranging from 10 to 90 nanograms per liter. PFOA was reported at 20 nanograms per liter and PFOS at 40 nanograms per liter. And I'm sure many of you are aware that's very high compared to where we are at today. In 2016, following the UCMR3 program, we moved on to the new revision 1.1, which was 14 compounds, but we added a 15th one, Gen X. We reduced our reporting limits for all compounds down to 4 nanograms per liter. And then in 2019, we moved on to the newest revision of 537.1, where we analyzed for 18 separate compounds, and we further reduced our reporting limit down to 2 nanograms per liter. Please don't ask me about EPA's naming nomenclature. I have no idea. It's very confusing for our staff, but currently we are on EPA 537.1. And then in 2022, we brought in EPA 533, which is 25 compounds. We maintained our reporting limit of 2 nanograms per liter, but a number of those compounds overlap with 537.1. So this is a table just showing all the compounds that overlap there on the far left, and then the other 2 columns, the compounds that are exclusive to each method. So at this time, you need to operate 2 separate drinking water methods to encapsulate the entire 29 compounds. So it's a little bit inefficient. We'll talk about that in a little bit. So increasing PFAS demand, why? Obviously, there's increased public attention on PFAS. Here at the district, we have new PFAS treatment facilities coming online all the time to remediate the PFAS problem in our basin. We're now on UCMR 5, which is the program. As I mentioned, the program runs every 5 years. And so we've just completed our first monitoring of in UCMR 5, where we have to analyze for both 533 and 537. And then very recently, the EPA proposed federal maximum contaminant levels for PFOA and PFOS at 4 nanograms per liter. And what that basically means is that any wells that are serving water above those levels need to be shut down until remediation is put in place. And so all of that adds up into needing to perform more testing. And so going back to 2016, our sample counts were down at 260. It was post UCMR 3, and there was a downward revision from EPA of the health advisory of 70 nanograms per liter for PFOA and PFOS. We see a slight uptick in 2017, and that's when we began at the district initially investigating sources and extent of occurrence in our basin. Counts stayed relatively flat into 2018. DDW began to establish notification and response levels for PFOA and PFOS. And then we see a doubling of our counts in 2019 at the beginning of the DDW state monitoring orders targeting a number of wells in our service area. And then this is where things really start to get a little bit crazy. Now we're at 1,700 or 1,800 samples per year. Further downward revisions to PFOA and PFOS. A little bit of an anomaly, a little bit lower sample count in 2021, but continuing to monitor sources and extent of the occurrence. On the left there, you see the Santa Ana River. So we do also do surface water and wastewater monitoring here in our lab. On the upper right, you can see what the resulting extracts look like when analyzing those types of samples. And then last year, we're almost at 2,500 samples. New notification and response levels set for PFBS and PFHXS at 503 nanograms per liter respectively. And also the beginning of the implementation of our treatment system monitoring. So at this point, new treatment facilities are coming online in our service area, and we're having to do a lot more PFAS testing. And that brings us to this year, where we are on pace now for about 4,000 samples, ongoing treatment system monitoring, and also the beginning of UCMR 5. And so this is just a graphical representation of everything I just showed. The trend line is pretty obvious. We're only heading in one direction. Where will we be in 2024? Who knows, but it's likely only going to be more than this year. But all of that planning is taking place right now in advance of 2024. And so this is just another representation of how PFAS has impacted our overall sample counts. So back in 2016, PFAS only made up about 2% of our workload versus now in 2023, it's making up almost 20% of our overall workload. It is important to note that annually, our overall sample counts for all methods remained relatively steady. So anywhere from 19,000 to 20,000 sample counts. So it took a lot of strategic adjustments on the part of our water quality staff, and we'll talk about that in a little bit. And so how do we meet those demands? Well, at the district, we've made a lot of investments in PFAS analysis. We have 3 C.HG LC-MS instruments that are capable to perform both 537 and 533 analyses. We've made investments in 4 Promochrome automated extraction units, and those have been lifesavers for us. They allow us to automate the extraction process so that lab staff can set it, add the samples in, and go perform other work. We have 2 TurboVap LV concentration units. Almost all of our organic section staff, 13 in total, have been trained on PFAS sample extraction, and at some point have probably extracted samples. We have 5 dedicated analysts to our 2 PFAS methods, and we'll probably be looking to train more in the future. That's a shot of our Promochrome right there. So we have 4 of those, and they can run 8 samples at a time. I mentioned strategic planning, adjustments, and coordinated reductions to our monitoring program. So I really have to thank our water quality staff and Jason for working with our various regulators to reduce certain programs so that we could accommodate these increases in PFAS sampling. We've also had strategic outsourcing of some complicated methods like 515 and 548, 5D6, and radiological testing, things that we used to do in our lab, but eventually determined that PFAS priorities outweighed the need to try and continue performing these methods. We've also been getting into the habit of making bulk purchases. This was also spurred on by the pandemic and all the supply chain issues that were occurring at the time. But now we purchase all of our supplies in 6-month or 1-year supplies in single lots so that we can verify the entire lot at once and know that all of the products and consumables that we're using for these analyses remain PFAS free. And that's a really important point because obviously PFAS is ubiquitous, it's everywhere, and contamination is easily found in a lot of things that we use. And so advanced testing has really helped us to streamline the process and make sure that anything we're putting into place can be used with confidence. We've done other things like changing our instrument tubing from Teflon tubing into other plastic parts like polyethylene to reduce the potential of leaching of PFAS into our instruments. And then, of course, instrument service contracts. So, having those contracts to make sure that our instruments are in top condition. I also wanted to highlight our PFAS cost savings. So what we actually do is in our lab is prepare standards in-house versus purchasing pre-made standards at a lower concentration. This has resulted in a savings of almost $50 per sample extracted. I mentioned we're on pace for almost 4,000 samples this year. So we're saving effectively $200,000 this year by making standards in-house. Purchasing stock standards that come at a higher concentration allows for longer shelf life. So it only further extends those cost savings. It also allows us in the lab greater control over the concentrations that we're adding to each of our mixes. Downside is obviously the labor and time that's required to prepare them ourselves and the potential for contamination of standards, but our lab staff are well trained, and we've very rarely ever seen issues with contamination of our standards. And so some future considerations. So I mentioned how we have to operate 2 separate methods to capture the 29 compounds of interest. EPA method 1633 is in draft form right now. It's a method targeted for groundwater, surface water, and wastewater monitoring, but does encapsulate 40 total compounds. So it's something we're potentially looking to bring into our lab. I mentioned that we do some surface water testing of the Santa Ana River. And so that's something we'll be looking to in the future. Vaughn's also going to talk a little bit about that method and how they're operating it in their lab. And then we, of course, as I mentioned, completing our third-party assessment in June 2023 to apply for certification and become T&I compliant. And then continuing to develop improvements in our citrus limbs to increase our lab's efficiency and paperless data reporting. And so I did want to highlight some of our lab's accomplishments over the last few years. So I wanted to note that we were the first California public agency lab to receive accreditation for both 537.1 and 533 in 2019 and 22 respectively. And I think that just goes to show the district's efforts to remain at the forefront of this PFAS problem. And we're very proud as a lab to be part of that. The UCMR 5 program, we are one of 50 total labs in the nation that are participating. Of those 50, there are only 30 labs that are participating in full, meaning they're analyzing both PFAS methods and lithium by EPA 200.7. In California, we're one of 3 public agency labs that are participating, and we're the only public agency lab in California that's participating in the program in full. So we're very proud of our UCMR heritage as well. And as far as PFAS data goes, I mentioned all of the treatment facilities. Every time a new facility comes online, we're required to provide data within 24 and 48-hour turnaround times. So that's a departure from our standard 2 to 3 week turnaround. Our lab staff takes great effort and pride in being able to meet those turnaround times. But the thing I'm most proud of, we're the current holders of the Lab First Water Quality Annual Bowling Trophy. If there's any water quality staff watching now, we'll see you guys in July. To their credit, they won like the first 7 of these things. So it's been pretty water quality dominant until recently. So in conclusion, some of the major challenges OCWD has faced, increasing regulations from T&I, need for updated technology, and increasing sample demands, especially for PFAS. How do we address these issues? We brought in Qualtrics compliance software, increased staffing. We've tried to modernize our LIMS system, and then advanced planning and scheduling and automation of our sample prep. And so, of course, I need to acknowledge my laboratory staff. They've been awesome. If you go back and look at the timeline of everything I've talked about today, all of these major projects began at the same time as COVID. They were in plan prior to COVID, but we ended up having to implement all of these things while dealing with COVID. It was a massive lift, and our lab staff have been great. They've put in all kinds of extra effort to get us to this point today, and I can't thank them enough and tell them how much I appreciate them. So thank you guys. Our water quality department, I mentioned the careful planning that they have, and also their understanding of the lab's needs and making sure to not overwhelm us with PFAS samples all at once. To our IS staff, our LIMS system, it wouldn't be where it is without them. I also have to give a special shout out to Tui Lam. She's the head of this whole project, and she's the one that's gotten us to this point where we can depart from our old LIMS and now start to make some real advancements in our processes. And to our engineering department, this modern building that we work in wouldn't be possible without them and their planning years ago. Although I do have to say all of these treatment facilities are also on them, so maybe they shouldn't be on this slide because it is a lot of extra work for us. And then also I have to acknowledge our board of directors and our upper management team. Without their support and their foresight and willingness to invest in all of these different things that the lab needs to operate at this level, we couldn't do it without their support. LCMS instruments are not cheap. And so, like I said, willing to invest in those things so that our lab staff can do what we do at the highest level possible. We can't thank them enough. And so with that, that concludes my talk. Thank you everyone for joining. Hope you all have a great day. And here's Jason to introduce Vaughn.
Thanks, Prem. Yeah, I'll now introduce our next speaker, who works for our neighbors over at the Orange County Sanitation District Laboratory. Yeah, I'm pleased to introduce Vaughn Ponsiri. Vaughn is a senior scientist at OC San and serves as a subject matter expert there on various emerging issues, including PFAS and pharmaceuticals and personal care products. He's also served as a technical lead on method development for both legacy and emerging contaminants to support OCSAN's NPDES permit compliance, core monitoring program, and the regional monitoring program. Vaughn has more than 20 years of experience in environmental testing and is an OCSAN technical representative on various efforts and has been with OCSAN for over 30 years. So welcome, Vaughn, and take it away.
Thank you, Jason, for the introductions. Really appreciate you and your team for allowing OCSAN participate in this webinar today. Welcome, everybody. Thank you all for joining us today. Because of a time limit, I'm just going to jump into my presentation. Next slide, please. Yes, yeah, I want to shift gears a little bit to the wastewater side. I want to share some of the analytical work that OCSAN has been involved in. Particularly, I want to share with you the PFAS method certification process, and maybe talk about it. Talk about the infamous method 1633, as far as what it is, what are some of the challenges implementing this method, and what are of the our OCSAN plan in terms of adopting this method. And finally, I will talk a little bit about how we mitigate matrix interference here in our lab. Next slide, please. So I'll start with the timeline of our PFAS laboratory accreditations. So you get an idea of how long it takes to get to be accredited for this method. So we start to develop our method back in 2019, and by the end of 2021, our methods were completed. We then applied for the accreditation through NELAC's Institute. So to become accredited, the laboratory must develop a method based on the quality control standard, and you have to demonstrate proficiency of your method through the on-site audit, and then you also have to pass your proficiency testing. TNI required 2 proficiency testing. So that's what we did. We completed our first PT study back in January 2022, and then subsequently we passed our on-site audit. And as of March 2022, OCSAN had became the first municipal laboratory of wastewater to be accredited for PFAS testing in the state of California. So at the time, I think about 10 laboratories were accredited, 9 of those for commercial lab. For TNI's accreditations, we did pass our second PT study back in May, and by August, we were accredited for 32 PFAS compound using method 537 with the Department of Defense Quality Control System Manual, version 5.3. I have some of the data that I'll show you toward the end of this presentation. Next slide, please. I'll talk a little bit about method 1633. Briefly, as Prem had mentioned earlier, this is a single laboratory validated method to test for 40 PFAS compound in environmental matrices such as the wastewater, groundwater, soil, biosolid, sediment, landfill, and fish tissue. This method utilizes isotope dilution, liquid chromatography, tandem mass spec, which is considered to be the gold standard of PFAS testing. So currently, EPA has completed the multi-lab validations, and they are evaluating the method, the result from those studies. Although it's not been promulgated yet, EPA did say that laboratory can use this method for monitoring purposes, certainly without challenges. So one of the challenges here is the fact that the method is still in draft form. So it's subject to change. So whatever change or modification you make, EPA require you to perform or repeat your initial demonstration of capability. So that can take additional resources from your lab. Secondly, it's the method in itself, it includes multiple methods. So I believe at least 3 or 4 methods. So for the laboratory to develop this method, you have to create a procedure for extracting clean water, wastewater, soil, and tissue. So this could be very challenging to manage this kind of workflow coming through your labs. Not to mention the training. You have to train your staff on various procedure here. And lastly, this method is come with very rigorous quality control criteria. There's a few things that I list here. Besides, you have to deal with 40 PFAS in your method. You also need to run instrument sensitivity check. So you have to the result has to be within plus minus 30% of your true value. And you also have to add 24 extracted internal standard in your sample before you extract. The very unique thing for this method, you also have to check the bioacid interference check. So I'll talk a little bit on the next slide about this. So bioacid surfactants, just like PFAS. So they present in high concentration in mainly the tissue. So, but they share similar quantitation ion or transition ion with PFOS. So they cannot be removed through the cleanup procedure, and the instrument that we use cannot differentiate between the two. So what you have to do is you have to chromatographically separate them. So this is actually the graph just from our contact lab, just to show you what I'm talking about. See on the top graph here is the PFOS. So the first peak that elute is about 5.77. And then the bottom here's some of the bioacid. The latest peak elute at 3.54 minutes. So this lab actually were able to achieve more than 2 minutes separation. EPA is required to have at least 1 minute separation. So they were well within the EPA requirement. Next slide, please. As terms of the plan for adopting methods 1633, this method certainly is going to be a method of the future for the environmental matrices. So we will definitely be required to use this method to monitor PFAS in our monitoring program. So currently we are trying to incorporate some of the EPA quality control into our wastewater method, and in the next few weeks we'll be validating the automated SPE system. As far as the sediment method, the work has already been underway. So once we complete with those 2 matrices, we'll try to develop a method for biosolids. So hopefully we can get this done by the end of the year. Next slide, please. Certainly, matrix interference on our side is it's a major challenges. So this is really detrimental to the accuracy and precision and sensitivity of the methods. So we really have to mitigate it. Here are some of the things that we try to do here at our laboratory. I'll talk about it individually in the next slides. So managing cross-contamination, we all know that PFAS is very ubiquitous. They are everywhere in everything. So they also, present in the laboratory environment as well. So the instrument can detect down to very low part per trillion. So that means that your reagent, your solvent, Your glassware had to be cleaned down to part per trillion as well. So many labs on the wastewater side had a lot of problem with cross contamination. We were very lucky that we don't have a lot of problem with cross contamination. So here are some of the things that we do here in our lab. As far as reagent water, we use this Alka Pure Lab Flex purification. So we start using the water from this purification since we started, and we have no issue with the PFAS contamination here. As far as methanol, this is what we use. We use Fisher Optima SPLC grade. This is actually were recommended by Prem's lab because they found that this particular brand do not have a lot of PFAS background. So we have not experienced any problem with this methanol. The other things that we do here is that we have our staff wearing cotton lab coats when they handle the PFAS samples. So that seemed to work well for us. Next slide, please. We do have a lot of problem with high percent solid in our sample. This is really can interfere with your SPE or solid phase extraction process. If you have sample with high amount of suspended solid and then trying to pass it through to your SPE cartridge, your cartridge will definitely clog up. So EPA said that if you have a sample with less than 50 milligram, you can use this method. But what we found out is that it's not just the solid contents. It also has to do with the type of particle, the size of the particle as well, because some of our sample have as low as 10 milligram percent solid in our sample, and we still have clogging with as far as when we try to extract the sample. What we do here, try to mitigate that problem is we centrifuge the sample and extract them separately, and then we combine to extract. The other thing you can do is try to minimize the sample volume, but you can, in some cases, might have to sacrifice your sensitivity a little bit because when you reduce your sample size, you also elevate your sensitivity of your method. So if you have sample with high PFAS, then you will be okay. So it's kind of a balancing act here between sensitivity and matrix interference. We do clean our extract, and EPA is required you to clean your extract with powder carbons or carbon powder. We start using powder, but it proved to be very messy. So we kind of switched to the stack cartridges from Monomex. And as you can see here, the carbon is actually being combined with the extracting material and placed at the bottom of the cartridge. So these cartridges seem to work well for us. Next slide, please. Isotope dilution, I had to say that this is probably the most important thing you can do to minimize your matrix interference. Isotope dilution is a calibration technique, just like the exact external standard or internal standard calibration. The difference here is that the isotope dilution, you have to add label analytes in your sample before you extract, and you use that to quantify against your native analytes. By doing so, you automatically correct the recovery. You also can mitigate some of the matrix effects such as ion suppression or ions enhancements. And definitely the result will be very highly accurate and precise. Next slide, please. As I mentioned earlier, we have some data that I want to show you. This is some of the work we did for the initial demonstration of capability. We work with about 36 PFAS compound, and this slide here just want to show you what they are. So next slide, please. This is the initial precision and recovery for the native compound. EPAs require you to perform the initial demonstration of capability, and where you have to analyze full sample of water and spike with the native solution and the extracted internal standard. This is the result that we get. So you can see full replicate that we did are pretty close in terms of the recovery. Next slide, please. And the mean recovery, I calculated the mean recovery here for the native compound. We evaluated against the DOD QSM 5.4 table B24, where the native has to be within 40 to 150%. So most of this recovery around 90%, and overall we were within the acceptance limit of the DOD 40 to 50, 150%. And for precisions, mostly in single digits, less than 6%. I think there's one that is above 12%. So, but they are well within the in-house precision recovery, so 30%. So EPA doesn't have criteria for precision, so we kind of rely on our in-house precision here, 30%. Next, please. Here is the initial precision recovery for the extracted internal standard. Again, from the full replicate that we did, all four are very close. Most of the recovery around 100% or slightly more. There's a couple of the compound that were below 60%, but overall well within the 20 to 150% of the DOD criteria here. Next slide, please. This is an average mean of the recovery. As I say, most of the recovery around 100% or slightly above, but they are within the EPA 20% to 150% criteria. And for the precision as well, they mostly in single digits, less than 6%. Next, please. I believe that's my conclusion of my presentation.
Thanks, Vaughn. Really appreciate that nice summary of OC Stan's work with PFAS analytical methods and highlighting the unique challenges sanitation agencies face when testing for PFAS. So this time we'll bring Prem back in as well, and we can try to address some questions from the audience, which again, reminder you can ask through the Q&A box. We've had a few come in already. We'll do our best to get through as many questions as we can today in our allotted time. And again, as a reminder, in the event we're not able to get your question today, our staff will follow up with you with the webinar, or alternatively, you can always send us an email at info@ocw.com. So let's start with the one I see right now in our in the question and answer box here. I'll put this to both of you. What type of funding help do you get from state and federal government to upgrade or expand lab capabilities, if any? Prem, let's start with you. Are you aware of taking advantage of these types of funding opportunities to help the lab?
The only one I know of is the Biden bipartisan infrastructure bill that was adopted in, I think, 2021 or 2022. So we've been looking into that to see if we can get additional funding from that. I don't know exactly what's come of that since we inquired, but that's the only one that I'm aware of. Otherwise, funding has come from our normal budgeting process here at the district.
Great. Okay. Vaughn, anything to add to that?
No, as far as I'm aware of, I don't think we have any funding from outside our normal budget. So yeah, I'm not aware of any other funding that will help with the PFAS.
Okay. Another live question here. Someone's interested in which labs do you subcontract to? Vaughn, do you have awareness of any of the labs you work with for testing outside of your lab?
Yes, we do subcontract our work out for the water board investigative order. We did sub out the contract to I believe SGS Access out in Canada, which is the one of the EPA laboratory.
Okay. And Prem, how about you? Where I know you mentioned a handful of methods we do send out. Are you aware which laboratories we typically use for that?
Yeah, so we use Eurofins Eaton Analytical Laboratory as well as WEC laboratories for some of those other monitoring. And I believe for radiological testing, we outsource to FGL laboratories.
Great, thanks. Another live question here. Will OCWD pursue microplastics analysis? I'm happy to take a crack at this, and then Prem, you're free to supplement. I would say in the short term, it's not something we're looking to bring in-house at this time. My understanding is the State Division of Drinking Water is still moving forward with method development and certification for that, and that once monitoring begins, it will be focused on drinking water, and I believe it's surface water systems that will be, targeted first. And so because we're, RGC is focused on groundwater, we don't see a significant sample load coming to us from a compliance perspective on that basis. But I'm aware of a couple agencies in the basin who operate surface water treatment plants who I believe are determining how they may address a future requirement to test for microplastics at those facilities. Prem, you want to add anything to that?
Not really. Other than the published methods that have been released by ELAP in conjunction with SCORP, they're not the most robust yet. I feel like there's still going to be revisions to those methods and the quality control aspect, and how do you maintain compliance, and it's a very difficult method to actually understand at the moment. And so yeah, we're keeping tabs on the entire process, but like Jason said, at this moment it doesn't look like anything that we'll be bringing in anytime soon.
Vaughn, you want to maybe just briefly mention OC San's kind of thoughts on microplastic testing and what you may be starting to think about there? Sure.
We actually some staff of our lab actually had participated in the method development. I think that we are collaborating with SCORP and probably Water Control Board as well, the Water Board as well. The method certainly is not quite ready yet. I believe they had made a few months ago to collaborate on how to move forward in terms of finalizing the method development.
Great. Okay. So just time check for folks. We're just about to hit 2 o'clock, which was the allotted time for the webinar. We have a couple questions left in the Q&A box that I think our panelists will be happy to ask, or answer rather. So feel free to stick around if you can. But if you need to take off because it's 2 o'clock, we understand and appreciate your attendance today. So next question here, I think we'll have you both take a crack at this. Has your lab ever failed a blind performance check? And maybe if so, which analytes were troublesome? And maybe I might add, I think folks will be interested to hear what you do in response to that. When should that happen? And I'm guessing this is probably within the context of PTs. So maybe Prem, why don't you take that first? What do we do in these situations?
Sure. So the state allows a failure to be repeated. So in the event that we do fail in reporting an acceptable number, we can order a new blind study, a separate lot, and perform the testing again. So in the past, we have on very few occasions, but sometimes about once a year, we'll fail one of the target analytes. And so we reorder it and we reperform it. If you fail the second attempt, then you are out of compliance and you do have to pause all compliance analysis until you've made the corrective actions and then proven upon a third time that that you can pass the proficiency test. So that has happened to us a number of times, but generally on the second try, we've always passed the PT study. So that's our process. I've never recalled a time that we've ever failed the second attempt at it.
And Prem, just to follow up quick, my sense is it's not like, at least in our experience, there's one method that proves more problematic than others. It seems a little bit random.
A little bit. I mean, with the number of samples we're analyzing, certain instruments at different times may be analyzing more complicated matrices and they're not in their most optimum shape. And so we may have some QC problems or things like that cause our results to not be fully within the acceptable range. So it's not any specific method that we always fail or anything like that.
Let me move on to our next question, but I think would be good for Vaughn. Vaughn, we have a question here from Eric Nelson about stating that the State Water Board is asking for PFHXDA, which is not covered in 1633. Do you know if we will have to use the DOD method for this analyte? And any insight you can provide into PFHXDA testing?
Eric is correct that it's not included method 1633. I'm not really sure as far as include or have to include this particular analyze in the method. Yeah, so I'm not really sure how to handle that. What we look at when we do method development to monitor or to test some of the sample that the water board was ordered us to do. We actually looking into that compound, but it's not a required. And I think it's probably an optional compound, so we did not add it to our method.
Okay, thanks, Vaughn. I just want to take a moment. We have a few more live ones. I'm happy to take those if attendees want to stick around. We did get one question ahead of the webinar that I can address just quickly. We got a question about asking, does the OCWD Water Quality Lab have any white papers on sampling methods or procedures for groundwater sampling? And I would just say that, both U.S. Geological Survey, USGS, and EPA have general field groundwater sampling manuals available online. A lot of good information there. And then specific to PFAS, both the state of California's Division of Drinking Water and the Division of Water Quality each have their own PFAS sampling guidance documents available. So I'd encourage folks to check those out if they're interested on, some of the procedures that are recommended for collecting these types of samples. Let's go to our next live question. Probably bring this one to you, Prem. Given the number of samples that has increased, and you talked about this, has this impacted hold times and storage in the lab? Has that been an issue?
Not particularly. I mean, when it comes to PFAS, actually, those are some of our smaller sample bottles. They come in 250 polyethylene bottles. So from a size and real estate standpoint, it's not that impactful. We've gotten into the practice of collecting samples in duplicate for all PFAS method or for all PFAS samples. We used to collect them in triplicate when we were more concerned, but due to the cost issues, sample bottles are not allowed to be reused for PFAS methods, so they're effectively one-time use, so that increases the cost significantly. but it hasn't really, in fact, impacted our holding times or storage. Our labs has gotten into a flow, and we've been doing this for a long time that we've been able to fold it in pretty seamlessly.
Great, thanks, Prem. And then Prem, looks like there's a follow-up on that, kind of related to hold time and preservation. Have we noticed any significant changes in concentration during the hold time or preservation? Have we looked at that at all, or maybe you've heard through your network if this has been an issue?
As far as like a time study beyond the method hold times, I don't think we've really done any kind of time study like that, because we've been operating in this strict compliance mode for so long. We typically don't even hold samples beyond the 28 days that the method allows. So, and that's also a space issue too, right? If we continue to keep samples beyond that, we're just going to accumulate more and more bottles. So I can't really speak to that. I don't really have an answer for that.
But the method does require either, ice during transport or refrigeration during that whole time, correct?
Correct.
There are temperature requirements that have to be met. Okay, great. Let's go back to you, Vaughn. And I touched on this briefly, but maybe you have some more specific information. Are there specific steps folks at the sanitation district in the lab who are out doing sample collection for, effluent or even your biosolids? Special steps your team has to take, Vaughn, to prevent contamination during sampling?
Yes, we do. I think typical procedures that we use here, we typically start off with decon our equipment, and also we also use the equipment blank while we're collecting our sample. Typically, the equipment blank is actually a reagent blank that we test for PFAS prior to use. So when we go out there, obviously all the staff have to wear all the gears that will not PFAS free actually. So a typical procedure is wearing the correct gears and do some decontamination of the equipment. And we do have a field blank that we monitor the cross-contamination from our equipment. So kind of a typical procedure that we use.
Great, thank you, Vaughn. Prem, let's hop back to you on this. You talked about kind of how the lab try to manage and optimize its sample load and make some decisions about what methods to keep inside versus outsource with the increasing PFAS demand. We have a question about the laboratory. Did we decide to drop any FOTs through eLab or do any outsourcing that was driven by TNI? Was TNI a driver in any of those kind of FOT accreditation or contracting out decisions?
The ones listed in the presentation, no, but we did drop other FOTs that we didn't regularly get, or maybe not at all. Some that we maintained as like backup to other FOTs, and so we did opt to drop those because TNI requires you to do certain steps to maintain those fields of accreditation. And so, yeah, we became more selective about what we wanted to be certified for or not. I couldn't tell you the number or how many. It was kind of gradually over time. We've dropped a few here, dropped a few there, but we have cut down our list a little bit in the years since TNI was adopted.
Great, thank you. All right, we're reaching the end of our time here. We have a couple final questions that maybe we'll take before we wrap up. And I think I might try to address them. We have one question regarding, are there any effective treatments for PFAS contamination today? I would say the short answer is yes, especially for drinking water. In the recent EPA proposed national primary drinking water standards for PFOA, PFOS, and for their PFAS, EPA highlighted kind of three main technologies. So granular activated carbon and ion exchange resins were identified as adsorption techniques that have been demonstrated to remove PFAS effectively from impacted drinking water, as well as high pressure membranes such as reverse osmosis and nanofiltration. So those are specifically called out by EPA as kind of existing technologies that have proven effective for the PFAS they're proposing to regulate. And then maybe one more question here. Let's see. Are there any areas where you think additional funding for PFAS would be most helpful? And so I'm sure both Vaughn and Prem would love laboratory space or laboratory equipment to be eligible for funding, if not maintenance. But I would think more broadly, yeah, I think certainly support for treatment systems, especially, you know, in response to EPA's proposed pretty strict standards for their national regulation. You know, many systems around the country, including beyond Orange County, are going to be affected by the proposed rule should it take effect as it's been proposed. And I think helping utilities around the country be able to implement those systems on EPA's desired timeline for compliance and public health protection is going to require more substantial federal resources to get that done on the timelines that EPA appears to be desiring. So I think we will close there. So don't go too far over time. We appreciate folks sticking with us. I just want to thank our speakers, both Vaughn and Prem today, for your excellent presentations and responses to questions. And I want to thank all our attendees today for tuning in. Hopefully you learned something new today, especially about how laboratories are managing PFAS and other challenges coming at them. And just a friendly reminder, this webinar has been recorded and will be posted on the OCW website and YouTube page should you wish to revisit it or recommend it to a colleague who might be interested in it. So thank you very much, and have a great rest of your Thursday.